In this section, we'll take a closer look at how electrons are arranged in atoms. We'll use the Bohr model and the electron dot structure to show electron arrangement. When drawing Bohr models, there are several procedural steps that need to be followed. We will use our periodic table to calculate Penn numbers, or the numbers of protons, electrons, and neutrons for the element. To help us with that, we have the mnemonic device APE-MAN. The atomic number, which is found on our periodic table, equals the proton number. And because our element or our atom is electrically neutral, the number of protons also equals the number of electrons. So it becomes our electron number. To calculate neutrons, we're going to find our mass number. So we'll look at the atomic mass on our periodic table and round that to the nearest whole number. And then we'll subtract the atomic number from the mass number. When we make that subtraction, we're left with neutrons, so our neutron number. Once we've calculated Penn numbers, we'll use the symbols for each of those to help us in our Bohr model. To represent the number of protons, which is located in the nucleus, we'll write the number of protons followed by a plus. To represent the number of neutrons, also located in the nucleus, we would write the number of neutrons followed by an n to the 0. We're going to use dots to represent electrons, and we're going to pair those dots after the first energy level to make it easier for counting. So we'll write the number of electrons per energy level followed by the E negative. Please note that each energy level can only hold a maximum number of electrons. The first energy level can hold up to 2 electrons. So we'll place up to 2 dots in that energy level. The second energy level can hold up to 8 electrons. So we will put up to 8 dots on the second energy level. And then the third energy level also can hold up to 8 electrons. So we'll use up to 8 dots in that third energy level. We'll begin practicing by drawing the Bohr model for hydrogen. Find hydrogen on your periodic table. Let's calculate the Penn numbers for hydrogen. APE-MAN tells us that the atomic number, which is 1, represents the number of protons and electrons. And to calculate N, we are going to take the mass number, which is the atomic mass rounded to the nearest whole number. And we'll subtract the atomic number from that, and what is left over is our neutron number. Working from the inside out, we'll start with our nucleus. The protons and the neutrons belong in the nucleus, so we write the number of protons followed by the symbol for protons. Then we will write the number of neutrons followed by the symbol of neutrons. And finally, we're going to use dots to represent electrons. So what we're going to do is, remember, the first energy level holds up to 2 electrons. We only have 1, so that will fit in the first energy level. We will write 1 followed by its symbol of electrons in the first energy level location. And then we will use a dot, a single dot, because we only have 1 electron, to represent the electron. So that is the Bohr model for hydrogen. Next, we will practice by drawing the Bohr model for fluorine. Fluorine's proton number is the atomic number, so 9. That is also the electron number according to APE. And then to get the neutron number, we're going to take the atomic mass and round it to the nearest whole number. Subtract the atomic number from that, and therefore we have 10 neutrons. Protons and neutrons belong in the nucleus, so we'll write the number of protons followed by its symbol, the number of neutrons followed by its symbol. We know that each energy level holds a specific amount of electrons. The first energy level can hold up to 2, and then the second energy level can hold up to 8. We will see that we have 9 electrons, so 2 of those electrons will fit in the first energy level. 9 minus 2 is 7. Since the second energy level can hold up to 8, the remainder 7 electrons will fit in that energy level. All right, now we need to use dots to represent those electrons. 2 of them belong on the first energy level. And then in pairs, we'll write the remainders of the 7 in the second energy level. So 1, 2, 3, 4, 5, 6, 7. When we count the total number of dots, we should end up with 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that is our completed Bohr model for fluorine. Our final example is drawing the Bohr model for sodium. Calculating the pen numbers for sodium by looking at our periodic table, we see that the atomic number is 11. Therefore, the proton number and the electron number is also 11. When calculating the neutron number, we're going to take the atomic mass and round it to its nearest whole number. Subtract the atomic number from it, and the remainder of those becomes our neutrons. Working from the inside of our Bohr model out, starting with the nucleus then, we write the number of protons followed by the symbol of protons. Then we'll write the number of neutrons followed by the symbol of neutrons. And looking at our electrons, we know that the first energy level will hold up to 2 electrons. 11 minus 2 is 9, so we have 9 electrons remaining. Only 8 of those will fit in the second energy level. So we have used 10 electrons, or we have placed 10 electrons. We still have 1 additional electron, so we'll place that in our third energy level, which also holds up to 8. Now that we have identified where and how many of them will be in each energy level, we need to go ahead and place those by using dots to represent the electrons. So there are 2 in the first energy level. There are 8 in the second energy level, and then 1 in the third energy level. We have just completed the Bohr model for sodium. Congratulations, you are now a Bohr model expert.